Hello everyone, and in this video we'll learn about the proof of E is equal to 2.71 dot 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 dot, isn't it? So first of all, what should we do? First we have to write what is our aim. Yeah, if we say our aim to derive the value of E is equal to 2.71 dot 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 dot. Okay. As we know that E is non-terminating because its decimal places has no lasting value, and E is also non-repeating, non-repeating, because when we talk about its decimal places, and when we see that's equal to 2.71, and it goes, but it doesn't repeat. So we doesn't put bar. Okay. So we know that E is not non-terminating and E is not repeating. So let's start this proof. So from Maclaurin series, from Maclaurin series, Maclaurin series, Maclaurin series. Have you heard about the Maclaurin series? Maclaurin series, Maclaurin's infinite series. Okay. Maclaurin's infinite series. What does it say? It says f of x is equal to x0 to the power j by 0 factorial f0 plus x to the power 1 by 1 factorial f dash 0 plus x to the power 2 by 2 factorial f double dash 0 x to the power 3 by 3 factorial f30. We can write how many tests we will put. So we can write 3 f30. Okay, no problem. X to the power 4 by 4 factorial f40 plus x to the power 5 factorial f50 plus plus x to the power n by n factorial fn 0 plus it goes to infinity. That is the Maclaurin's infinite series, as you have heard when you reach in the semester 1 BSc Maths Honors in semester 1. Then you will read about Maclaurin series, Taylor series. Okay, so that in there you will learn. So f of x is equal to this, and let what we have to find? We have to find the value of e. So let f of x is equal to e to the power x. We can do, no problem. If the function of x, f of x is equal to e to the power x, then e to the power x is equal to, I have written, I can write in this form also. I cannot write fg, I can write in this form also. I can write the Maclaurin series in this form also. But I have written, why I have written here? X to the power 0 by 0 factor. Actually, x to the power 0 by 0 factor is what? X to the power 0 1, and 0 factor is also 1, that is equal to 1. I have written in such a manner that it looks like a series. X to the power 0 by 0 factorial f0 plus x to the power 1 by 1 factorial f dash 0 plus x square by 2 factorial f double dash 0. So you see that it looks like a series. 0, 1, 2, 3. 0, 1, 2, 3. It's looking like a series. That's why I have written like this. Okay. So you can easily remember also the Maclaurin's infinite series. Okay. Let's move ahead. Let's move ahead. So coming to the Coming to the expansion of e to the power x, that comes under the chapter expansion. Okay, that comes under expansion. The topic is basically expansion, isn't it? I can give some knowledge expansion regarding that. Some knowledge I can give some knowledge regarding that expansion. This is what we are doing. We are doing the expansion of e to the power x. Okay, so x to the power 0 by 0 factorial. What we see? X to the power 0 by 0 factorial. We have written. Let's see. First of all, we write here f of x is equal to e to the power x. Okay, no problem. What is f dash x? That is e to the power x. What is f double dash x? That is also fx is equal to e to the power x. When we differentiate e to the power x with respect to x, it will become what? If we differentiate e to the power x with respect to x, what we get? E to the power x. Okay, no problem. So in here, f dash x is equal to e to the power x, and again we differentiate e to the power x with respect to x. What we get? E to the power x. Then again we differentiate, and it goes like this: f3x, that is will be e to the power x, f4x, f4x, f4x. I've written f4x, f4x, f4x. That is also e to the power x, f5x. That is also e to the power x. That goes on f and x. That is also e to the power x. If you see f0, what will be f0? E to the power 0, that is equal to 1. F dash 0, that is also e to the power 0, that is 1. F double dash 0, that is also 1. F30, that is also 1. F40, that is also 1. Similarly, in all the cases, you will see F50, that is equal to 1. Fn0 also, if you see Fn0, that is also equal to 1. No problem up to here. Let's see, you are seeing downside or not. Okay, okay. Let's move ahead. So we have noticed over here that the f of x, f dash x, f double dash x, f3x all have the same values, and here also all have the same values, that is 1. Okay. Firstly, write down this. Okay. Because I will rub this. Okay. I will erase this portion. So write this. If you have not written, then you will back my video and you will see what I have written over here. Okay. Let's move ahead. If we proceed further, then we see over here x to the power 0 by 0 factorial f0. What will be f0? F0 will be 1. What we have written? We have earlier written, isn't it? X to the power 1 by 1 factorial f dash 0, that is also 1. X to the power 2 by 2 factorial. And that is also why I have written up to 5, up to 5th. 1, 2, 3, 1, 2, 3, 4, 5, 6. Why I have written up to 6th term? Because I have to go up to 6th term in order to get the value of e to the power. In order to get the value e is equal to 2.71 dot dot dot. Okay. So x square by 2 factorial f double dash 0 is equal to 1. S cube by 3 factorial, that is also 1. S to the power 4 by 4 factorial, that is equal to 1. X5 by 5 factorial, that is also 1. Plus dot 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 x to the power n by n factorial, x to the power n by n factorial, fn0, that is also, and it goes up to infinite series, infinite. It goes up to infinity. Okay, no problem. If you see here, e to the power x, x0 by x to the power 0 by 0 factorial, x to the power 0 1, and 0 factorial is also 1. So 1 by 1 is equal to 1, as you have shown, as you have seen earlier. Okay, as you have seen earlier, 1 plus x plus x square by 2 plus x cube. What is 3 factorial? We can write 3 factorial as this, or Factorial is like looking like this or like this. You can write in this both manner. In both manner you can write factorial. Okay. So what is 3 factorial? 3 factorial is equal to 3 into 2 into 1, and that is equal to 6. We know. What is 4 factorial? 4 factorial equal to 4 into 3 into 2 into 1, that is equal to 24. 5 factorial, again you can say 5 factorial. 5 into 4 into 3 into 2 into 1. 5 for the 20, 23, 60, 62 the 120, 120 into 1, 120, that is 120. Okay, so let's move ahead. We can do the expansion up to here. Up to here we can do the expansion. Okay, so x cube, because up to here we can reach to our value, isn't it? So we cannot move ahead because this is the infinite series. Okay, so x cube by 3 factorial, that is 6. 3 factorial is 6. So we will write over here 6. Okay. So x to the power 4 by 4 factorial. What is the value of 4 factorial? 4 factorial is equal to 24. So x4 by x to the power 4 by 24 plus x to the power 5 by the value of 5 factorial. What is the value of 5 factorial? 5 factorial is 120. 120. No problem. 5 was a 20, 20 to the 60, 60 to 120, 120 to 120. 5 factorial is equal to 120 plus dot dot dot. We can reach right up to here. Okay. In order to reach to our aim, that is E equal to 2.7. What we have to prove? E is equal to, what do we have to prove? Proof E is equal to 2.71 dot 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 dot. No problem. Okay, what we do? Put, or we say let x is equal to 1. Let x equal to 1. So e to the power 1 is equal to 1 plus. Or we can do like this, replacement. We can do the replacement. Instead of x, we can write 1. Both side, bs. Okay. So 1 plus 1 square. Bs means both side. Bs means both sides. Okay. So 1 square by 2 by 1 cube by 6 plus 1 to the power 4 by 24. 1 to the power 5 by 120. Let's see the calculation. E is equal to 1 plus 1 by 2 plus 1 by 6 plus 1 by 24 plus 1 by 20. Sorry, 1 by 20. 1 by 20. 1 by 20. 1 by 120. Okay, no problem. 1 by 120. This is 1. This is 1. This is 1. Okay. 120. First, we will solve this. Okay. Let's remain. If we solve the value of E, then we get. Let's solve this value. Yes, see. Okay. So E is equal to 1 plus 1. 1 plus 1, 2. 2 plus 1 by 2 plus 1 by 6 plus 1 by 24 plus 1 by 20. 120, sorry. So if we solve all this, what we get? LCM of 1, 2, 6, 24. 2, 6, 24, 120. 2 is 2, 2 is 6, 2 is 24, 2 6 is 20, 120, sorry. 3, 1, 3 1 is 3, 3 4 is 12, 3 20 is 60. 2, 1, 1, 2 is 4, 2 is 10, 20. 2 is 4, 2 is 20. 2, 1, 1, 2 1 is 2, 2 5 is 10. If we find the LCM, we see 2 into 3, 6, 6 into 2, 12, 12 is 24, 24 5 is 120, 24 5 is 120. 120 is the LCM. 120 is the LCM. Okay, no problem. 120 is the LCM. Or we can also find the LCM in short trick also. Short trick also. Okay. So 120 is the LCM. What will become the 120 will become LCM, and 120 divided by 1 equal to 120. 120 into 2 is equal to 240 plus 120 by 60 to 60 plus 120 divided by 6. 120 divided by 6, that is equal to 20 into 120. 120 divided by 24, 5 into 1, 5. 120 divided by 180 equal to 1 into 1 into 1. Okay. Then solve 240 plus 60. 300, 320, 325, 326. 326 by 120. That is the value of E. Okay. That is the, we can say approx. That is the approx value. That is the approx value of E. The value that we are finding, that is a approximate value. Okay. Because it is not terminating and not repeating also. Isn't it? Okay. Okay. So 326 by 120, 202, 1 2 6 is 2, 2 3 is 202, 1 2 6 is 260. I am erasing this portion. Okay, this portion. Let's see. What is 163 by 60? 163. If we divide 163 by 60, what we get? 61 is 60, 62 is 120, 62 is 120, 61, 60, 62 is 120, 63 is 180, 3, 4. Okay, no problem. 67 is 420, 0, 1, 0, then 0. 61 is 60, 0, 4. And it will go like this. So 163 by 60 is equal to 2.71. So therefore, we have proven, yes, that is an approximate value. Basically, this gives an approximate value. Okay, because it is non terminating and non repeating. So E is equal to, finally we can write E is equal to 2.71 approx. Okay. Okay. So we have finally proven the value of E is equal to 2.71 . So thank you.